The Colorado State logo and Colorado Department of Education logo appear center screen. The video transitions to on-screen text that reads, "Use and connect mathematical representations." With the logos now at the bottom of the screen, the on-screen text transitions to new text that reads, "Effective teaching of mathematics engages students in making connections among mathematical representations to deepen understanding of mathematics concepts and procedures and as tools for problem solving, principles to actions, NCTM." A full-screen graphic appears on screen that reads, "Continental Army Movement." During the American Revolution, a group of patriot soldiers is marching between camps. Each day, the soldiers travel 3.5 miles. Their journey lasted 5.5 days because they had to stop partway through the last day. Meanwhile, a group of loyalists tracked their movement and recorded the distance traveled each day. Your task: 1. How far did the Patriot soldiers travel in total? 2. Create a data representation showing how the distance adds up over time from day 1 to day 5.5. 3. Based on your representation, write a sentence to answer the following questions. What pattern do you notice about how the distance changes each day? How does your model help prove your total distance is correct? 1. Key takeaways. 2. Exit ticket front table. 3. Digital math game.
I really wanted to take a peek at question 2, though. It says, create a, what's that word?
Data representation.
Data representation, showing how the distance adds up over time from day 1 to day 5.5.
The full-screen graphic disappears. A graphic appears on screen that reads, Mrs. Randall's 5th grade class, Broomfield, Colorado. The text graphic slides away. Mrs. Randall walks across the room to a whiteboard.
So let's break down the word data representation. Okay, we haven't got into the problem yet, so your mind might be not quite certain about how you're going to be organizing this.
Mrs. Randall stands in front of the whiteboard addressing a class of students.
But if I'm asking you to create some type of a visual representation of data over time, meaning from the first day that the soldiers travel all the way to their last day, 5.5 days later, you're going to be having to record that information. Give me an example of what a data representation might be.
Students raise their hands as Mrs. Randall calls on them to speak.
Okay, Max?
Blindfold.
Okay.
Mrs. Randall writes the students' answers on the whiteboard.
What else? Who else? Reese?
A boulder.
Okay.
A text graphic appears on screen that reads, Why have the students list different types of representations? The text graphic slides away.
Ever?
Maybe a quarter plane.
Okay. I'm going to do this. Does that work? Okay. Ryder?
Area model.
Okay. Is an area model going to represent data over time? I'm not sure, but I'm going to put it down here because it's a visual representation for sure. But then your group might have to just kind of decipher if that's going to work or not, right? Okay. Think back to fractions. When I ask you to create fraction models or place fractions on a number line, would an open number line potentially work here? Okay. All right. I'm going to do this. Okay. So I will leave it up to your groups to think about the best visual representation. And what I love about it is there's more than one way. So I'm looking forward to seeing how you guys come up with that.
The video transitions to 3 students facing the wall with a whiteboard on it while writing out their answer to a problem.
1 times 3 is 3 halves.
Wait, no. Yeah,
And then 3 times 3 is 9. And convert that.
would be 1.5. So it's 10.5.
Yes. So number 2 would be 10.5.
Yes. Okay. Olivia, do you want to multiply?
Mrs. Randall walks up behind the students and looks at their work.
4 or times 3.5?
Mrs. Randall points at the students' work.
Oh, good improvement. Thanks for adding that unit.
Yeah.
Okay. What would you call this representation?
A line plot
You'd call it a line plot?
or open line or
Open number line?
Yeah.
Yeah. Okay, so I'm not going to say what I would call it. I think that those are both good thoughts, and then maybe when we have a discussion, we'll see what the class would refer to that as.
Okay.
So It is a data representation, and so what are something that you can add so that if someone were to come in, they would understand what do these numbers represent and what do those numbers represent? What
Okay.
might be something you can add?
Um,
I'm going to leave you with that question, okay? And I'll swing back around.
The video transitions to 3 students gathered around a whiteboard on an easel as they write out their answers to a problem.
On day 1.5, they made that. On day 2.5, they did 7 miles. On day 3.5, they made that. And they made that. And on day
Mrs. Randall walks up behind the students and looks at their work.
they made here, right? So kind of like that. It goes up and up to show how many miles they got.
A text graphic appears on screen that reads, "What mathematical representation do you notice on the students' boards?" The text graphic slides away.
So that's kind of like our model. Yeah, makes sense.
What would you guys call that representation?
A bar graph.
A bar graph. And so I noticed the part of the question right here
Mrs. Randall points at the students' work.
that says over time. Do you think this is a visual representation that shows like the trend, the change?
Yeah, like
Yeah,
over time.
because they also stopped part way.
Okay,
So
Alright.
like we can show that going like that.
right.
So
Okay.
they get more miles every time.
So here I see you converted this to a decimal, right? And then how did they become whole numbers? Did you use your estimate to place your decimal?
Yes.
Ah.
Change them to whole numbers.
Okay.
And then we got 1,925. And we did 6 times 3 equals 18. And then it wouldn't make sense to do any of those, so we did that.
So 19 and 25 hundredths. Where else is that represented on your board, Kinsley?
Right here. For 19.5 miles.
You guys are really quickly able to go back and forth between those representations. That's great. Good job. Okay, looking good.
The video transitions to on-screen text that reads, "What is the value of students using multiple representations for the same problem?" The video transitions to the Colorado State logo and the Colorado Department of Education logo.